Hello, welcome everyone. Welcome to another episode of Sound Talk Show. We are going to code Wolfram language today, and if you are watching this offline, skip around, okay? Because I talk slow, and this is probably gonna be an hour or an hour and a half. Now, at the end of code, as they go into day 10 or 14, we're gonna do day 14. 2020 23, so last year day 14. So when the later problems gets complicated, and usually last time I took 6 hours and not done. So I'm just gonna go code it easily and for an hour or two, and if I didn't finish, then that's okay. And so play at speed 2 or skip around, okay? When you are watching offline, you have to skip around. If you are here, say hi. So let's begin. Let's see how many people I have. Nobody, okay. Oh, one guy, Kea. Hello. Hello, Kea. I remember you last time. So Wolfram coding, Wolfram language, okay? So we're gonna start. So my keyboard, Glove 80 keyboard, Ultimate Hacking 2 keyboard, Nulia trackball, these are fantastic. Okay, check out, search for them on YouTube, you will find them. I have video reviews of them. Okay, advent of code, 2023, problem 14, day 14, okay? I haven't read the problem yet. I'm gonna go slow, okay? Here's some red wine to soothe my soul. So what I hope to achieve is that you can learn some Wolfram language, which is a term rewriting system. Basically a programming language that's different from all that you've seen. And in the past month, I have been working on my Wolfram language tutorial a lot, especially on the pattern matching. So basically, pattern matching, if you do functional programming such as Haskell or Camel or Erlang, you might know somewhat. But Wolfram language pattern matching is symbolic. That means basically, essentially what Wolfram language, the way it does computation, is just transform expressions. Like your source code is just like a string. So whenever you write a function, you call a function, it's actually doing transformation of the source code. So it's somewhat like Lisp macros, but it's far advanced. So imagine if you are coding Emac Lisp, every function is macro. That's essentially what Wolfram language is. Okay, you don't actually have like normal functions. Every function is like just transforming your source code. And we have live stream talking about that before. So anyway, in the past few days, I've been working on a comprehensive, in-depth coverage of Wolfram language patterns. So anyway, so here's my tutorial. Search for Wolfram language tutorial, you'll find it. Wolfram language in depth, and you can download it, the Wolfram script, for free. Okay, I'm looking forward to buy that keyboard you recommend me last time, Expose, yeah. Okay, let's start to code, okay? Let's see how far we can go. Day 14, parabolic reflector dish. You reach the place where all of the mirrors were pointing a massive parabolic reflector dish attached to the side. Okay, in short, if you move the rocks, you can focus the dish. The platform even has a control panel on the side that lets you tilt in one of the 4 directions. The rounded rocks 0 will roll when the platform is tilted, while the cube-shaped rock # will stay in place. So 0 will roll, # stay in place. You note the positions of all of the empty spaces, which is dot. Okay, and rocks, your personal input, for example. Okay, so you got a personal input like that. Okay, start by tilting the lever so all of the rocks will slide north as far as they will go. Okay, so 0 is where you can tilt. Pound sign is no. And dot are spaces. So 0, so that means 0 can move up. So whenever you see a 0, it can move up. So all of the rocks will slide north as far as they will go. Okay, so they will move all the way to the north. What exactly is the problem? So you got a bunch of parabolic mirrors. Okay, whatever. So anyway, 0 will move up all the way. Okay, you notice that the support beams along the north side of the platform are damaged. To ensure the platform doesn't collapse, you should calculate the total load on the north support beams. Looks like you want to determine what is the eventual result for the first line. Okay, the amount of load caused by a single round rock is equal to the number of rows from the rock to the south edge of the platform. The amount of load caused by a single rounded rock, okay, amount of load, is equal to the number of rows from the rock to the south edge of the platform. The number of rows from the rock to the south edge of the platform, including the row the rock is on. Cube-shaped rocks don't contribute to load. Okay, so the amount of load caused by each rock in each row is as follows. Amount of load caused by each rock in each row. So first row is 10. How do you get 10? I don't know. Let's see. The amount of load caused by a single round rock is equal to the number of rows from the rock to the south edge of the platform. So you count the columns, the number of 0 in the columns below, something like that. So let's see. 1, 2, 3, 4, 5 zeros. So, but you got 10. That means is amount of load caused by a single round rock is equal to the number of rows. Number of rows from the rock to the south edge of the platform, including the row the rock is on. So let's see. 1, 2, 3, 4, 4, 3, 7, 7, 8, 9, 10. Okay, so basically for each 0 in a row, you want to count all zeros below it, but not including when you reach a rock. Okay, so the first column, we are doing the first row first. The first row, it's magnifying. Okay, so so we are doing this row first, and we do each column. So the first column is 4 because there are 4 zeros below. The second column is 3 because there are 3 zeros, including itself. The third column is just 1 because there's no 0 below it. You know, you stop at the pound sign. Okay, the fourth column is 1. And this whatever this column, there's no 0 below it, so it's also 1. So you got 4, 3, 4, 3, 1, 1, 1. So 4, 5, 6, 7, 8, 9, 10. So that's why it's 10. Now let's check the second column. It's 9. What? Wait, why is it 9? The amount of load caused by a single round rock. So the amount of load caused by each rock in each row, okay? Amount of load caused by a single rounded rock is equal to the number of rows. Oh my god, this is gonna take hours. Equal to the number of rows from the rock to the south edge of the platform, including the row the rock is on. Cube-shaped rocks don't contribute to the load. So the amount of load caused by each rock in each row is as follows. So the second row, we got 2 zeros, and why is it 9? So why is it this 9, 10, 8, 7, they seems to be in order? Oh god. 9, I don't understand this 9. Hello care. Okay, so okay. The total load is the sum of load caused by all of the rounded rocks. In this example, the total load is 139. Why is it 139? Is it because 1 add to 10? I don't think so. 1 add to 10 is not 139. So let's do some Wolfram language. So you do sum 1 to 10. x, okay? So x goes to 1 to 10. That's called, that's 55. So that's not, that's not 136. So how do you get 136? Tilt the platform so that the rounded rocks all roll north. Afterwards, what is the total load on the north support beam? Okay, what is a support beam? Does it just mean the north support beam? Does it just mean row 1? Okay, so you have to read the problem, the elf shit. Oh god, I'm gonna do this problem today. Are we gonna do it? Yeah. Let's try to have fun, okay? The dish is made. Okay, so you reach the place where all the mirrors are where all of the mirrors were pointing a massive parabolic reflector dish attached to the side of another large mountain. This dish is made up of many small mirrors, but while the mirrors themselves are roughly in the shape of a parabolic reflector dish, each individual mirror seems to be pointing in slightly the wrong direction. If the dish is meant to focus light, all it's doing right now is sending it in a vague direction. Stupid English. This system must be what provides the energy for the lava, whatever. Okay, so if you focus the reflector dish, maybe you can go where it's pointing and use the light to fix the lava production. So you just need to fix this mirror's direction. Upon closer inspection, the individual mirrors each appear to be connected via an elaborate system of ropes and pulleys to a large metal platform below the dish, okay? The platform is covered in large rocks of various shapes, okay? Depending on their position, the weight of the rocks deforms the platform, and the shape of the platform controls which rope move and ultimately the focus of the dish. Shape of the platform. Fucking stupid English, stupid story. In short, if you move the rocks, you can focus the dish. The platform even has a control panel on the side that lets you tilt it in one of 4 directions. The rounded rocks 0 will roll when the platform is tilting. Okay, so you got like a slab. Okay, on this slab is a grid. It's a grid of things like this text. Okay, So some of them are pound sign. Pound sign are just like fixed whatever thing. The zero is the how does it roll? If you move the rocks, you can focus the dish. So what? So the rock is a mirror. Upon closer inspection, the individual mirrors each appear to be connected via elaborate system of ropes and pulleys. The platform is covered in large rocks of various shapes. Depending on their position, the weight of the rock deforms the platform. How is that significant? So anyway, personal input. So you got this. Start by tilting the lever, so all of the rocks will slide north. Okay. So when you tilt, let's see if we understand the problem. Okay, all the zero moves up. Okay. So let's look at these two. Yeah, so these two and this second column moves up. Yeah. Okay, you move it, all the zero rows to the north. Okay. You notice that the support beam along the north side of the platform are damaged. To ensure the platform doesn't collapse, you should calculate the total load on the north support beam. So it looks like you just need to find some kind of a number for row number 1. Okay, that's what it means. The amount of load caused by a single round rock is equal to the number of rows from the rock to the south edge of the platform, including the row the rock is on. Okay, pound sign doesn't count. So the amount of load caused by each rock in each row is as follows. So the first row we determined it's 10 because it's 4, 3, 1, 1, 1. That's 10. Okay, the second row is 9. We don't understand how it works. I don't understand how it works. So the amount of load caused by each rock in each row is as follows. So it's saying this text block is actually the load for each row, the number, but I'm not understanding the second row. So the third row is 8. Let's see, 1, 2, 3, 4, 5. No, I don't get why it's 8. Then, okay, so the amount of load caused by each rock in each row is as follows. Amount of load caused by each rock. Fucked up. So the total load is the sum of the load caused by all of the rounded rocks. So you want to get the sum for all rows. In this example, the total load is 136. It's not 136. So how did you get 136? Sum 1 plus 2, according to the row number, 1 plus 2 plus 3 up to 10 is 55. Does that make sense? Yeah. Let's see. 10, 20, 30. Yeah, about 55. That's correct. Because you add them, by pairs. But how do you get 136? The total load is the sum of the load caused by all of the rounded rocks. The amount of load caused by a single rounded rock is equal to the number of rows from the rock to the south edge of the platform. Okay, but first of all, you roll them to the north, right? So this is your personal input. You roll them to the north, and you got this thing. But I don't understand the load. Do you guys understand the load? Tilt the platform so that the round rocks all roll north. Afterward, what is the total load on the north support beam? Okay, there's something I don't understand. How do you get the number 136? Amount of load caused by each rock in each row is as follows. Oh, God. This 9 doesn't make sense. What about this one, 8? Oh, wait, do you have to count also the one above? No, the amount of load caused by a single round rock is equals to the number of rows from the rock to the south edge of the platform. So you don't count whatever is above it, right? So for the second row, why is it 9? Now if we count the thing above it, 1, 2, 3, 4, 4, 3. If you count above it, it's 4 and 3. 4 plus 3 is 7, so it's not 9. So what is going on? Equals to the number of rows from the rock to the south edge of the platform. So it is the number of rows, not the number of rocks. So the number of rows from the rock to the south edge of the platform, including the row the rock is on. Cube-shaped rock don't contribute to the load. So let's try again. So the second row, number of rows. So the first column in second row, how many? Let's see, 1, 2, 3, 4, 5, 6, 7, 8. Okay, 8. Now the second column, let's see, 1, 2, 3, below, okay, from below. So the first column is 1, 2, 3, 4, 5, 6, 7, 7. The second column is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so if you add 7 and 9, it's more than 9. So that still doesn't make sense. God. The crap. Am I drunk? I've had, I had 100 milliliters of red wine, which is a quarter of a cup. I'm not drunk. Oh God, this is not doing good. Support beams on the north side of the platform are damaged. To ensure the platform doesn't collapse, you should calculate the total load on the north support beam. The amount of load caused by a single rounded rock is equals to the number of rows from the rock to the south edge of the platform, including the row the rock is on. So let's try to row 1 first again. Amount of load caused by a single round rock, 0. So 0 is important. We just want to deal with 0. Okay, is equal to the number of rows from the rock to the south edge of the platform, including the row the rock is on. Okay, but excluding the pound sign. Okay, so let's count row 1, column 1. 1, 2, 3, 4, 5, 6, 7, 8. Row 1, column 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's already 18, which is more than 10. So this number is incorrect. So that means our interpretation is wrong. What the fuck are these numbers? 10, 9, 8, 7. You see, it says, so the amount of load caused by each rock in each row is as follows. So it, by chance, this amount of load for each row happens to be descending consecutive integers, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Why is that? I don't know. So for example, the last row, the amount of load caused by each rock in each row. You see, it says caused by each rock. It didn't say caused by all rock in a row. It just says caused by each rock. What the fuck is the... Okay, do I make sense? Are you guys watching? God. I don't know what's going on. Just immediate problem, just understanding. I was using this ergonomic chair, but now I feel like using the standard chair. I don't understand the problem. You should calculate the total load. So the goal is to calculate the total load. So given an input like that, but first of all, you need to move all the zeros to the north, okay? Wait, so given an input like that, first of all, you need to move all the zeros to the north. But let's understand. So you move all the zeros to the north, right? Yeah, you do that. So are these two images the same? Yes. So first of all, you move all the zeros to the north. Then you need to find the amount of load on the north support beam. It just means the row number 1. Total load is the sum of the load caused by all of the round rocks. In this example, the total load is 136. Okay, so you notice that support beam along the north side of the platform are damaged. To ensure the platform doesn't collapse, you should calculate the total load on the north support beam. So first of all, you need to calculate the total load on the north support beam on row number 1. Okay, but then eventually you need to, the total load is the sum of the load caused by all of the rounded rocks. Okay, so there are two things I'm not understanding. First of all, for each row, I don't understand what's their load. This number doesn't compute. Secondly, if you add all these numbers, 1, 2, 3, 4, 5 to 10, they don't total to 136. So this means there's something I'm misunderstanding. Okay. But am I missing some description of the problem? I don't think so, because all the above is irrelevant rather. So the most important thing is really, first of all, you move the zeros. Okay, you move all the zeros to the north. That I understand. How do you program that? I don't know, but anyway, we understand the problem. But then the problem is the load thing. Okay, it's already 36 minutes, and I'm not understanding the problem. The support beam on the north side of the platform are damaged. To ensure the platform doesn't collapse, you should calculate the total load on the north support beam. What the fuck is north support beam? That just mean the row number 1, right? Okay, Noob says, I think the total load is a weighted sum. Dag Rock has a load to the number in the side. Could that be right? Dash Rock? What do you mean? You got a typo. Okay, so we hey, can we magnify this? Oh God, this Google Chrome. So I'm on Windows, so that would be that plus. Where is plus? Total. So you are thinking it's some kind of weighted sum, okay? Weighted sum. Each rock has a load equal to the number in the side. Each rock has a load equal to the number in the side. Okay, something about weighted sum, basically, but I'm so you roll the 0, you move all the 0 to the top, and hello John, you roll the 0 to the top, you move the 0 to the top, then you get this, this picture. Okay, then you notice that the support beam along the north side of the platform are damaged. Okay, to ensure the platform doesn't collapse, you should calculate the total load on the north support beams. There is an S there. So maybe the north support beams is not just the row number 1. I don't know. The amount of load caused by a single rounded rock is equal to the number of rows from the rock to the south edge of the platform. So here it uses the word edge, while over there it uses the word beam. So north support beams. Okay, I'm not sure what that means, and I mean not exactly. And the south edge of the platform, does that mean just the bottom row, including the row the rock is on? Okay, don't contribute. Okay, so the amount of load caused by each rock in each row. Okay, I don't exactly know what you're saying, but you are suggesting there's some kind of weighted sum. Weighted sum. Oh, weighted sum. Oh, okay. Oh. Okay, so for example, in row 1, for every weight or whatever, you have to multiply by 10. In row 2, you have to multiply by 9. Something like that, okay? So let me try again. The amount of load caused by a single rounded rock is equal to the number of rows from the rock to the south edge of the platform, okay? So you basically count all zeros in that column. including the road the rock is on, okay? Cube-shaped rock don't contribute to the load, okay? Equal to the number of rows. Is it number of rows or number of rows that contains 0? You know, this division of code is really not the best puzzle. You know, this got lots of English description problems. This white guy's got English problems. Not totally logical. Okay. So let's just focus on the problem, including a row the rock is on. So let's try again. The first row. One, two, three, four, five, six, seven, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. The total load is the sum of the load caused by all of the rounded rocks. Oh shit! I'm having a problem understanding this. We're focusing on doing this problem, okay? Not other questions today. The top rocks add to 50, so looks like Noob knows what's going on. Oh shit. 5 times 10. Oh, Noob's got the answer. So the number 1 is just 5 times 10. Oh, so the number here is weight. So, okay, I got it. Oh shit, I'm so stupid. So the number, here is a chart. The number is just the weight you have to multiply. So for each row, you just count the number of zeros in it. So the first row is got 5 zeros. 5 zeros times 10 is 50. Okay. The second row, you got 2 zeros. 2 times 9 is, 18. So by this way, you just, that's why supposedly this answer is 139. Let's check. 136. Exactly. Fantastic. Thank you. Okay, so it's just weight. Oh, so that's why it's saying the amount of load caused by a single rounded rock. Okay, so it's saying each zero has a weight. And the weight of that zero is, oh God, it's so stupid. Yeah, so these numbers are the weight. And the way it's derived, it happens to be 10, 9, 8, 7. It should be, that's just by spec. Because the second row, there are 9 rows below it. The third row, there are 8 rows below it. So that's why the weight is 8. The fourth row, there are 7 rows below it, including itself. So therefore, its weight is 7. Then, these numbers are just weight. So you just multiply the number of zeros times the weight, and you get the total load. Okay. So in this case, it's 136. Okay. So far we understand the problem. Okay. Tilt the platform so that rounded rock or road north. Afterwards, what is the total load on the north support beam? Okay. Now you see another tricky jargon we didn't understand before. The north support beams basically means the entire thing. It's not the first row. So the north support beams is just the entire thing. The whole thing is something called north support beam. Okay, something maybe we missed. We missed the description. Oh yeah, the north maybe refers to the Santa Claus north, something like that. Okay, so anyway, so it looks like we understand the problem. So let's regroup. So you got an input like that. You move all the zeros to the north. Then for each row, you count the number of zeros and you multiply by basically the total number of rows minus the row number, the current row number. So there are a total of 10 rows. The current row number starting count with is 0. So 10 minus 0 is 10. So the weight is 10. You multiply, okay? Okay, understand the problem. I understand the problem now. So how do you code it? Okay, so the first problem is move the 0. Thank you, Noob Noob. The first problem is move the zeros, okay? So ultimately, you just want to count, you just want to, ultimately the problem is very simple. For each row, you want to find the number of zeros. That's basically all, that's a gist, that's the essence, okay? Once you got that, then the number of zeros multiply by a number. The number is mechanical because it basically just row number reversed. That's a weight. For you count the number of zeros, multiply by the inverse of the row count, the row number, then you got a number. Then you just sum it, okay? So, so the ultimate problem is count the number of zeros. So, but the first part is that you need to move zeros up north. So how do you do this programmatically? Let's see. Interesting. So this is some kind of like, if you have a physical puzzle, you just push it. But if you're gonna do it programmatically, how do you do this? So move 0 up. Of course, we first, the easiest, most simpler way, the naive approach is simply go through row by row. And for each row, you check each 0. You check if the north side of the 0 is a dot. If it is, you move the 0, okay? Then you can you can continue. Then you have to repeat. You can then repeat and repeat until there's no more change. This is the most elementary. So basically, first of all, you create a matrix. Now you can do this by just lines of string, multiple lines of a giant of a string, or you can convert it to matrix and use the column number and row number to determine the neighborhood. So which way is easier? It looks like matrix is easier. Okay, so you convert this thing to matrix. Then to move 0, you just check, if it's, if it, whatever above it is a dot. Okay, then you move. So that means you reset the matrix, then you start over. Or you can continue until you reach the end entry, then start over. You have to repeat this until no more changes are made. Okay, that's one way. Now, another way, there's a trick. You can transpose the matrix so that you don't have to, if you want to check the north neighbor, you don't have to go to the previous row. Because if you transpose the matrix, then all you have to do is just move 0. If there's a dot before it, just move it. Okay, so yeah, that's definitely easier. So you transpose the matrix and move. If you move 0, if whatever before it on the left side is a dot. Okay. So much talking and no coding. This is my style. Okay, analysis is the problem, then code one shot. Now it's already 50 minutes. I don't think I can do it. It will take another hour. So anyway, so yeah, so is it absolutely true that you should transpose the matrix first? Yes. Okay. Now transpose the matrix is a solution. So once you transpose, so then the problem becomes, instead of moving the 0 to the north, you just move all 0 to the left, which is much easier because we are dealing row by row. So for each row, you move all 0 to the left, okay? But how do you code that? Let's see. Yeah, well, you can, okay, so for each line, you can split the string. You know, suppose we transpose already. So for each line is a string. Then you split the string by the pound sign. Okay. Then inside it, you know, then for each list, you move the 0 if there's one. You move all 0 to the left. You count number of zeros and you count number of dots. Then you can construct a new list where the left is all 0, the number of zeros, and right is number of dots. Okay, then you put back the pound sign. Yeah, so the first step is just move these zeros. Okay, so transpose and so we got the algorithm now. You transpose. In fact, so you transpose, then you move them all the zeros to the left. Okay, basically that's the algorithm. So once you do that, once you got that, what's the next step? Then it becomes trivial. Then you just count number of zeros and multiply by the reverse of the row number. Okay, we got the algorithm. Okay, now start to code, I guess. Yeah, got shitty problem. Okay, so we got today's input. We already copied it before, so here's today's input. It looks like that. Okay, so we are ready to code, and today, from past experience, we should really just code it quickly and don't worry about fancy coding or using patterns or whatever, because that you'll never finish. The best way for a live stream is just simply do whatever you can to solve the problem. Okay, so but before we do anything, so let's begin with this this toy input. Okay, let's just do as we go. Okay, and we're gonna take a break in about 10 minutes. Okay, something. Input equals to okay, so that's the input, the Wolfram language code. I'm using Wolfram language mod. So where is it? Wait, something is wrong. What? Okay. Why is this not working? Wait, what? Okay, this cut, delete that. Okay, so we should be here. Okay, run it. That's just a string input. Now, how do you turn it to a matrix? Now, do we want to work with string or matrix? Yeah, we want to make a matrix because otherwise, for a string, it's harder to transpose. Yeah, okay, let's turn it to the matrix. Okay, so string split. Okay, string split, we're gonna split the string. Okay, so X input, and by default it will do it split by white space. Okay, so we got that. Then you want to, for each line, you want to turn it into a list, okay, of characters. Okay, so I believe the command name is characters. Check the documentation. Wolfram language documentation, characters. Give a list of characters in a string. Okay, magnify. Good. Okay, so characters, for example, let's try that. Do that, run it. So now a string becomes, each one becomes characters. So you want to call this function for each of the input. Okay, rows. Okay, row string equals to that. Okay, and you want to, for each row string, you want to map. Okay, map row string, a list of rows, and we, okay, and what do you want to map? You want to map the characters function to it. Okay, so this is matrix. Okay, so this is actually matrix. Run a code. Let's see the matrix. There it is. Okay, now this is a matrix. We got, this is the first row. Anyway, this is a matrix, and each entry is a character. Okay, a string. Okay, so we got the matrix, and and now transpose. Okay, transpose. Completion transpose X matrix. Okay, transposed. Okay, let's say matrix new equals to that. Okay, now copy the whole code. Let's run in Wolfram language so it's like more beautiful. So you can see there it is. Okay, now let's magnify so you can kind of see better. Okay, so output 7. So output can be shift. So that means output 7. So we want to do it in a, okay, there it is. Okay, so that's a matrix, right? And transpose, right? Output 7 is already transposed. So that's X matrix new. Okay, X matrix new. Fantastic. So what's next? So we got a transpose. Now we just need to move each one of them. Okay, move the 0. So let's pick a row. Let's pick let's see. Okay, let's see this one. So this one, because this one we got more things to do. So this row, now what we want to do is for any 0, if there's a dot in front, we want to move it to the left. Okay. So for example, here's the input. We're gonna just toy with this input. How do you do that? So okay, so move to the left. Is trivial pattern matching. The superb power of pattern matching applies. Yeah, good idea. Noob. So we're gonna move the 0 to the left. How do you do that? Pattern matching. Okay. So let's say x. So wait. So what do you do is, okay, you call replace all, and the input is that, and you want to replace by certain pattern. This pattern will be so this pattern will be the pattern will be something, a string with a dot, and then something of a string of 0. Now that's not 0, that's actually O. Okay, I got confused all this while. Yep, that's a capital letter O, so it's not 0. So O capital. So you want the pattern such that, let me show you the pattern, okay? So 0 or more, 3 low line means 0 or more anything, okay? And 0 or more anything followed by 1 dot, followed by 1 0, then 0 or more anything. Okay, so that's a pattern. So once you found that pattern, you want to change it to this arrow. So you want to change it to, so we need to give a name to the 0 or anything, x and y, okay? Let's say front, back, okay? Head and tail, that's a common computer science jargon, head and tail, okay? So once you find that pattern, you replace it by head is the same head, okay? Tail is the same tail, but here you swap them, okay? Okay. So I think that works. I think so. Do you think so? Yes, I think so. And we can try it. Do it. Okay, so originally we got dot pound dot 0 dot. Okay, now dot pound 0 dot dot. Worked. Fantastic and beautiful. Okay, so you see the power of pattern matching. If you're gonna do this in Python, it'll take you a day. Or Haskell. Actually, Haskell, maybe not. Haskell, maybe they can do the same. But you have to apply the pattern multiple times correct. So what we have to do is we call replace all. You're getting ahead of me. Noob. Fantastic. Replace or repeat it, something like that. I forgot what's the name. Okay. Check Wolfram tutorial, pattern matching. Okay, so just go to Wolfram language tutorial, scroll down, then on the left, pattern matching, syntax transform functions, pattern syntax there, okay? We want syntax transform functions there. So these are functions that allows you to do this transformation. So replace all is one of them. There are several of them. So you got replace all right here. Then you got replace repeated. Okay, so what these do is it will do replace all just like before, but it will repeat until no more changes. Okay, so that's what we're gonna do. Replace all repeated completion. Wait, what's the name? Replace repeated. Okay, not just there it is. Okay, so basically we want to do the same thing, except instead of replace all, just replace repeated. Okay, now in this particular example it doesn't do anything because it only takes one step to move the 0. So you want to try, let's try it. Okay, so dot 0. Okay, let's try that one. So if you use the replace all, for example, you know, this 0, there are 2 dots before it. Okay, so if you try that, paste, run, did it even work? No, it did not even work. What's going on? Dot pound dot dot 0. Okay, here the output is dot pound dot dot 0. No change. What? Something, what? Wait, our algorithm, you know, pattern. we got stumped. All the happiness before is mistaken. Okay, so dot pound dot dot 0. Oh, not 0, it's O. Fucking stupid. This stupid advent of code. Fuck. Okay, not 0, it's O. Okay, so let's make sure. Okay, so if you try that, let's try that. Do it. You see, it worked. Dot pound dot dot 0. Now it becomes dot pound dot 0 dot. Now if you do it again, you know, with the output above, then you got dot pound 0 dot dot. You see, so you have to repeat. But now if we do this, replace repeated, it'll just do it for you one shot. So the input is dot pound dot dot O. The output is dot pound O dot dot. Fantastic and beautiful. Okay, so we got it. So that's the main thing we're gonna call. Okay, and we want to do this to all rows. Okay, so very easy. So all we have to do is just map. Okay, so let's do a map. Wait, so what? Oh, in fact we don't even need to map to each row, because by the dint of pattern matching, we can simply match the whole matrix. You see, this oh, fantastic. Took 1 hour to understand the problem, but now we're making some progress. So replace repeated the whole matrix. Why would it work? Why would it work? Because let's see, the whole matrix, you know, we transpose it, right? We transpose it, then we transpose. Okay, so why so if we match the whole matrix, where is the matrix? The matrix is here. Will it work? Yes. Why? Because, you know, each row is not dot and is not 0, so this will not match a row. It will. This rule will only match when this rule matches. It will only be inside the row. Put it that way. Okay. So if we do this, let's just run it. Shift enter. Okay, so you can see all the 0 has moved to the left. Fantastic and beautiful. You can visually check all the 0 has been moved. Okay, so now all you have to do is transpose it back. Okay, transpose, and we use a add sign. Add sign is a shortcut syntax for the square bracket. It's like a prefix notation, so you don't have to go back, go over there and put the end bracket. So this is, so we can do that. Okay, so try it, do it. So compare this to the original input. Let's see, let's compare to the original input. Okay, so is it true that all the 0 has been moved? Okay, so this is hard to see, so let's try it here. All the O moved up. Oh yeah, we can compare. Actually, there's an example here. So the first row 0 0 0 0 0, correct. Second row 0 0, correct. Third row 0 0 0 0, correct. Okay, so we got it correct. Okay, so close that. So now all we have to do is count the zeros. Okay, so yeah, count the zeros. So okay, so this line is move all O to north. Okay, now next we want to count the zeros. Okay, so you need a new matrix. What? So this is the moved result. Okay, let's say O moved. Okay, I got a wait, where's O? Okay, oh God, something. Okay, so this is a new result. All we have to do is count each row, count the number of zeros, and multiply by row number. Okay, so we're gonna do a map. Okay, map to this thing. Okay, matrix, and that basically map to the rows. However, when we map the row, we need the index of the row, because the index of the row, when it serves as a weight. Okay, so but we want it reverse, but the gist is that we need the index, so we use map indexed. So map is a functional way of doing a loop, and map index is a functional way of doing a loop when you also need the index of each item. Okay, so you say map indexed. Okay, so you want to map to this thing, matrix, and what is a function you want to map? Okay, function, write a function. You want to, so x is the row. Okay, so x is a row here, and you want to count the number of zeros, number of O in that row. Okay, so you just count. Okay, double check, look up documentation, the count function. Count gives the number of elements in list. Okay, matching a pattern. Again, we are using a pattern. So we want count in X, and the pattern is not, okay, so capital O. Okay, so once you count, then, okay, the map index the function needs two numbers. Okay, let's say var and index. Okay, I believe that's the order. So let's look up map indexed. Map index map a function to an expression, and the function is given path specification for each element, a second argument. Okay, so here is the index. Okay, it's actually a list because it's a positional anyway. So you got a count. You got count multiplied by total number of lines. Okay, so you need total number of rows. In this case, it's just 10. 1, 2, 3, 4, 5, 6. Yeah, it's 10, we know. But in our personal input, it's not 10. So we need to some kind of count, okay? So total number of rows, we need to count total number of rows. Actually, we don't. Yeah, we do. Yeah, because you need to inverse the row, the row number. So you do need to know the total number of rows. Okay, so you need to find total number of rows. Okay, what? God, what happened? Okay, so you go here. You need to compute the total number of rows. Matrix is a row count. Is there a row count? No. Wait, how do you just length? Okay. Row count. Okay. Row count equals to X matrix length. Okay, so you got that. So row count is the length of matrix. That's right. So now you go back down all the way back here. So you want to times the weight. So what is the weight? The weight is something about the total row count, the minus the current index. So yeah, this index is actually position. Okay, so you need to get it the first element. Okay, so total row count minus the index, that is the weight. Okay, so you multiply that, multiply by that, that's that. Okay, so this is a function. This function, okay, then you need to sum it up. So wait, so this function returns a count, then multiply by weight. Now, did we get weight right? Is there some off by one thing? So let's see. 10. So this is the first row. So Wolfram language is 1 based index. So first row is 10. So you need to plus 1, something like that. Minus index plus 1, okay? Plus 1, okay? So this returns a number. Then it's a list of number. Then just say total, okay? Total at this thing, okay? I think that's it. So let's try that. I think that's it. We get 136, okay? Now let's try the whole code. Let's remove things we don't need. Okay. Yeah, so these are just sample code we don't need. Let's move sample code to here, okay? I mean, that just shows it's a testing code, okay? But now we go back here. So in fact, we make them whole line, one single line, because that is a natural way to do things in Wolfram language. You put them things in a single line. Kind of like that, okay? So let's see. Yeah, so copy all, go to Wolfram language, paste it. We should have 136. Let's try it. 0. Oh, shit. Okay. something syntax something. Okay, so why is that? So double check is all moved correctly. So what is the all moved? That looks good. Then the map indexed. What? Let's try the map indexed. Why is 0? Well, let's remove the count. Okay, let's just return for now xvar. Xvar is the row, okay, and then x index. Okay, let's see what it's actually doing. Yeah, so xvar is a row, then the index is that. Yeah, so when we, so if we extract the index, yeah, so we got the, you know, the index. So why is this function not correct? This part, row count, did we get the row count correctly? Let's see, row count is 10, that's correct. Row count minus the index. What does count return? Count returns a number, right? Let's try it. Wait, we don't even get a matrix. Shit. Okay, let's try that. Yeah, it returns a number. Count returns a number. So when you count it, oh yeah, okay, so we change it to xvar. So this is variable name is incorrect. How idiotic. Okay, xvar. Okay, so now we can kind of copy the whole thing, do it over. 136, beautiful. Okay, now we're gonna try the real input. Okay, make a backup, put it back, color syntax it, show in browser. Here's today's code. Beautiful. You know, the whole thing can become one single line because we made so many redundant variables. It like one single line, no variables at all, 0. But let's focus on the problem. So we gotta get our input. So let's try to get our user input. The user input is this huge text. Okay. Okay, we can try to read string. How long is this? Okay, 100 lines. Yeah, let's not read string. You know, but fuck it. Let's just put the whole thing here. Okay, make it easier. You know, because at the end of code, they never cares. You know, they never care if you actually think a lot. They just care about what is the answer. You know, like the C++ idiot. Okay, so we go back to Wolfram language. Okay, go back to Wolfram language, paste it. So we got this huge input. Okay, so huge input. Let's select all, paste. Okay, so this huge input, then we, okay, so let's put, okay, huge input, then we, you know, then just this one single line. Okay, run it. What is the answer? 111339. Okay, let's copy that. Copy back to Emacs. Go to the bottom, paste it. Okay, that seems good. Go to advanced of code. My answer is that. Are you sure? Yes, I'm sure. Submit. That is the right answer. Fantastic. Okay, so that's 90 minutes, close to 90 minutes. I hope you guys like it. Fantastic. Thank you, Noob. Monkey says, I'm in my first year of mathematics. Fantastic. Undergraduate studies, taking a programming elective. Okay, that's good. And do you have any recommendations to succeed in this course in future endeavors? It's in C. Oh, taking a programming elective. Well, it depends on what exactly is your question. So you are in your first year of math, undergraduate, and also taking a programming elective. I suppose that's kind of like secondary course. And you are saying that the language is C, right? Yeah, but what is exactly is your question? That's kind of, mentioned several things. So, okay, just in general, yeah, study math, good for you. That's also my obsession, especially when I was younger. Mathematics, that's great. For the first 2 years of math, usually you don't really need you don't really need university. Well, it helps, but it's not really necessary, especially today. I'm just giving you some random advice, okay? Now, if you have specific, say it right now. We're gonna close in 3-5 minutes. So in general today, because the internet is so advanced, so much educational videos, mathematics and website, there's so many good ones that you can learn calculus by yourself if you are really into your interest, your obsession in the subject matter is the most fundamental importance. If you have little interest, if you study math because your mom told you to or your dad, then your chances of doing great in that subject is not good. Doesn't matter you go to school or whatever you do, okay? So the fundamental important is the will, like the way they say, the will, the power of the will, okay? If you have an interest in math, you will do good. Okay, so going to university, it's okay. Yeah, you have to pay though. Maybe your parents pays for you, the expensive, but okay, so you go to school, study math, great, and you have the interest, great. So you are saying, but you are also taking a programming course on the side. Now, in the same way, programming today, you don't need university at all, especially programming, more so than mathematics. Because programming is actually just hand-on. If you graduate from university and you go to a real-life job, you can't do much shit, because real-life programming is very different from industrial, actual, real-world programming. In school, when you study programming, it's kind of a lot concepts, a lot theories, some theory. There's a section called computer science, theoretical computer science. You may not study it much until if you major in computer science, then you will later on. Anyway, for programming, it's even less necessary to go to school. In fact, for programming, I would recommend you do not study at school. You need just code, start to code like this. For example, my YouTube video today, we try this thing. We try to do this thing. If you're gonna try to do this thing from a computer, like educated from academia, you have no idea how to do this, okay? Like there's no, this is matrix multiplication, therefore you do it this way. There's no someone telling you what steps to take. You just have to do it yourself. So anyway, for learning programming, it's not necessary to go to school. In fact, it's recommended you just code. You just have to code a lot. Okay, doesn't matter what language you program in, Wolfram language or Mathematica, or Python or others, or C. Read the manual. Okay, well, C, in the case of C, they don't have a manual. They don't have actually supposedly a manual, but there's a lot online. Okay, so read the documentation of that language. Read a lot, code a lot. That's how you succeed in programming. Okay, so so I suppose that's my my recommendation. You have a great passion for math. That's great. And mathematics and programming, they are very different things. Okay, mathematics and computer science, mathematics and theoretical computer science, they have a lot to do with each other. Okay, a lot to do with each other, but still they are kind of separate. Okay, because anyway, I'm not gonna go into detail. So mathematics and theoretical computer science, there's a lot of connection. Okay, but if you go to university, taking a class called computer science, they don't teach that much theoretical computer science. They teach you what is operating system, how does networking works, like the internet, how does it work, what is the operating system, when you're Windows or Mac, how what made it work. They maybe teach you some CPU, like hardware, something, assembly language. So you learn a bit of, or what is a database, you learn, or maybe how to do game programming. All those are not theoretical computer science. So in fact, all those are not science at all. But they do teach that, when you take a computer programming major. So anyway, but for actual programming, which is not computer science, okay, like what we are doing today, this is not computer science. You need experience. You need reading a lot programming language manuals. Okay, like I've read Wolfram language manuals for since 1990s, cover to cover, 1,000 pages. So that's why I know it. So read manuals and code. That's all you have to do to become very good for real life programming and real life jobs. You don't need going to a school learning what is algorithm or what is database. You don't really need, you're not for practical job. Okay, that's it today. Thank you guys for watching. So if you like my videos, go to xali.info and you can pay me. Okay, I request a payment. Okay, you can Patreon me, Amazon gift card me, or PayPal. xali.info at the bottom of the page. Thank you guys. Bye guys. So we're gonna clean up this code and put it in the web, so you guys can, if you're gonna code this, you can look up and study the problem. Okay, bye.